All right, everyone, this is Vedram, and in this video, I want to talk about Pycaret. How to install the latest version, the 3.0 is out, and what are the features available. So let's dig into it. Okay, so what is Pycaret? Pycaret is an open source, low-code machine learning library, which is in Python, that automates machine learning workflow. Well, the idea is that it can be used to replace hundreds of lines of code with just few lines. And you can spend less time on coding and more time on analyzing. This has been the trend in the industry. As you know, just a week ago in December 2022, OpenAI released ChatGPT, which is a large language model based on GPT-3. Basically, you can literally use that model, ChatGPT, for getting some rough ideas for coding and even debugging your code. So it seems that the need for coding from scratch is becoming less and less, which this helps you to be more efficient data scientist and focus more on the analyzing part. So Pycaret is just another Python package that helps us to automate this process laid out on the right-hand side. It helps us to do the EDA, explanatory data analysis automatically, to do data preprocessing, model training, model explaining, and of course some MLOps. Basically taking the machine learning models to production and then maintaining and monitoring them. So as I said, Pycaret is essentially a Python wrapper around some famous and popular packages in machine learning, namely scikit-learn, XGBoost, LightGBM, CatBoost, and a few more. Okay, now should you use Pycaret or not? The answer is most probably yes. If you're a data scientist who prefers to work with a low-code machine learning solution simply to increase the productivity, and yeah, the answer is yes. Or if you're a professional who wants to build a rapid prototype, definitely Pycaret is recommended. But you should be careful. This is not a one solution to every problem, to every data set. So depending on the nature of the data set, you may end up working with specific models rather than using Pycaret, right? So, but at a high level, the good thing about Pycaret is that you can compare 2025 underlying machine learning models with each other by simply literally running two lines of code. And then you get a sense, an idea that, okay, maybe these top three models are the better ones for this data set. And then you can take those models and dig deeper for tuning the hyperparameters, at the very detailed level, right? Then Pycaret is also used at higher level to just ensemble models to blend and stack them. And usually, those stacked models or blended models are the are good candidates for winning competitions like Kaggle competition. All right, so before doing anything, we should pre-process the data. So this is what it's called set up the experiment. So in the experiment, we can literally set up the data preparation, scale and transformation, feature engineering, and feature selection. So in this video, I'm not going to go over all the details, but in the future videos that I'll talk about applied regression using Pycaret or classification, I'll open up the documentation and talk about all these features. But for now, just be aware these things are available using Pycaret. You can handle missing values, you can play around with the data types. Of course, you can do one-hot encoding, ordinal encoding, you can handle the cardinality of the feature space variables. You can handle unknown levels, you can deal with target imbalance with different methods, how we can handle when the data set is imbalanced. Of course, you can think about how to remove outliers with different methods. So this is for the data preparation. When it comes to scale and transformation, you can do ordinary normalization, feature transformation, and of course, target transformation. Then for feature engineering, there are some cool underlying properties or capabilities that you can use. Basically, you can do feature interaction automatically. You can think of polynomial features to be added to the feature space. You can group features based on their characteristics or their nature. You can think about bin numeric features. Basically, if you have a numeric feature which is not necessarily linearly scaled, you can think about it to put it in different bins. So FICO score is one of a good example for that. You can combine rare levels or you can create clusters, as the pre-processing step, right? And for the feature selection, of course, we can basically remove multicollinearity with different thresholds. We can use PCA to come up with the lower dimensional space first and then apply the machine learning models in that lower dimensional space. And we can think about ignoring low variance of the features. Again, we can set up a threshold and say that, for example, ignore these variables that has low variance, right? So again, I'm going to talk about the details of all these things in the applied videos. Okay, now after setting up the experiment, basically pre-processing the data, it's time to train the model. Well, Pycaret trains multiple models simultaneously and output a table comparing the performance of all those models by considering quite a few number of performance metrics actually. So as of now, for regression, there are 25 machine learning models built in, and I think 18 classification models and quite a few models for the clustering and anomaly detection. So the things you can do for training the model, you can train one specific model. So for example, if I run this line of code, create model, and specify what is that model. So for example, here I'm creating a decision tree model. And again, there are lots of features that you can play around with. I'm going to talk about it in the future videos. But at the very high level, you can create a single model and save it as an object. Or you can run this line of code, which is compare models. And if I do compare models, and then it's going to go ahead and, for example, for classification, it's going to go ahead and look at 18 underlying models, built-in models, and save the first, let's say, the top n performers based on their accuracy in an object, right? And I can call that object top 5 performers, right? And you can also easily tune these models, to tune the hyperparameters of the model. So imagine I created a model, I call it DT, and that was the name of the model, which is a decision tree. And now I'm tuning that model that I call DT with the custom grid search. Okay, so this is the model training step. So as I said earlier, there are quite a few number of models already built in Pycaret. So, and here is a laundry list of the regression models, for example. So uh, again, the available models for regressions are linear regression, lasso, ridge, elastic net, least angle regression, lasso least angle regression. And you can go through the list yourself, but you can see all those popular regression models already here, the random forest, KNN, and the more advanced models as well. For example, the boosting models, AdaBoost, gradient boosting, XGBoost, and light GBM and CatBoost. So you have access to all these models for regression. Then for classification, here's a list of the models for classification. Again, I think there are 18 of them, and most classical models are already here, and some of them are less well known, but still you can use them. You can literally train any of these models separately. SVMs, KNN, yeah, you can go through the list on your own. The same story for clustering, k-means clustering. We have agglomerative clustering, basically a hierarchical clustering, and dbScan clustering, k-most clustering if your feature space is all categorical. What is missing here, at least as far as I know, is the k-prototype clustering, which when you have a mix of continuous feature random variables and categorical ones. But of course, you can use different other packages like kmode in Python to use k-prototype clustering. And for anomaly detection, same story. And here's a list of models for anomaly detection. You can use PCA for anomaly detection, and basically some other models. You can pause the video, go through the list, but you can also find all this information in the Pycaret documentation API as well. Okay, now after creating and training your model, it's time to analyze and interpret it. And it cannot be easier using Pycaret package because you can do tons of visualizations for classification, regression, and clustering by using simply one line of code. So imagine you created your model, maybe it's a random forest, and then you do plot model, random forest, and then give me the type of the plot. So these are the types. You can, for classification, you can look at AUC curve, you can basically look at the threshold, precision recall, confusion matrix, and all other good stuff. So for example, you can look at the learning rate, you can calibration curve, you can look at feature importance if it is a boosting model. So, and the good thing is that the underlying package of the Pycaret is scikit-learn when it comes to visualization, and of course all the other parts. And if you're already familiar with scikit-learn, the transition can be super easy and you can appreciate this simple one line of code. So for example, I don't know, you can look at the clustering plots. If you want to imagine you're doing k-means clustering and you want to use a silhouette method to figure out what is the optimal number of k's. And you want to see within cluster and between cluster fluctuations or variations, right? If you want to do it using scikit-learn package, so it's easily 10 lines of code, but now it's simply one, right? So you do plot model, name of the model, and the type of the model. So for example, here cluster is equal to silhouette, right? And these are the available plots for regression. So you can obviously look at the residual plot. You can look at the learning curve if the model has a high bias or variance, for example. You can look at manifold learning or feature importance, and basically you can look at the parameters. So imagine you have tuned the model, you want to see what are the parameters of that tuned model, right? So as you can see, there are lots of things you can do. You can plot using Pycaret easily with simply one line of code, and it's going to speed up your analyzing part, so you don't need to spend time on coding these things. Yeah, and the next thing is interpreting your model, right? So if you run this, this is a function called interpret model, and you have to simply pass the name of the model here. And under the hood, the Pycaret is using the Shapley package, the Shap package. And there are some other cool stuff that you can use there. So I'm going to show you some examples in the applied part. All right, now that we have created the model and looked at some visualizations and interpret the ones that are interpretable, it's time to finalize it, make some predictions, save the final version of the model, and maybe deploy it for later use. Okay, so, and the steps are pretty straightforward, just like any other function that we saw already. It's just one line of code, and then you can basically apply these things to your model, whatever you named it. So let's say we create a model, we call it my model, we can finalize it. So this function, basically this finalize function is going to train a given estimator. So imagine this is random forest on the entire data set, including the holdout set, right? So basically the idea is that when you're creating a model, there is this, let's say there is 100% of data. 80% of it is going to be trained, 20% is going to be holdout set. So this is a name that Pycaret used. So basically that's, it don't want you to confuse it with the test set. And so it's using cross-validation under hood to tune the private parameters, let's say. And then after that, let's say we are happy with the cross-validated performance metrics, we can finalize that model. And this finalized model is going to be applied to the entire, that 100% of the data, right? Then we can use predict model function to simply make predictions. We can make predictions on the holdout set. We can make predictions on a data set that the model has not seen in the entire process, right? So we can call it unseen data set. Again, I'm going to show you some examples in the applied part. And once we are happy with the model and we have made some predictions, we can save it. So this function literally saves the transformation pipeline and train the model objects into the current working directory. It's saved as a pickle file for simply to be loaded later on. Okay, and of course we can deploy this model. We can deploy the entire pipeline and the trained model on cloud. So for example, you can deploy it on AWS, GCP, or Microsoft Azure. Okay, that's it. That was the entire workflow of Pycaret. So just to wrap it up, I'm going to show you some snippets for classification, regression, clustering, and anomaly detection. Basically, the idea is to show it to you how simple it's to use Pycaret and to compare 2025 underlying models with basically, I don't know, 4 or 5 lines of code, you say. So let's look at the supervised version first, and then in the next slide, we're going to look at the unsupervised example. So for example, for classification, you just need to import the data. Imagine you have a train set, test set, and then you say from Pycaret.classification, let's import everything. And then remember the steps. We have to set up the experiment first. So you're going to say set up use the train data, and this is my target variable, and a bunch of other properties that it can change down the road. But this is the minimal things that you need to put. So what is your train set? What is your target variable? And then next step, you can compare the models. You can say, select 5 of them and call it the best top 5, right? So under the hood is going to compare 18 models based on their accuracy, for example, and then save the top 5 depending on what number of n you selected in an object called best. Then you can evaluate the model, and you can, as I said, you can make predictions, and basically you can save the model, right? So this is at the low level what we can do with Pycaret. It is a lot more involved, and I'm going to show you full detailed examples in the next videos. For regression, the same story. So the only difference is that we are importing stuff from Pycaret regression, and we're importing everything. So one thing that I want to emphasize about Pycaret 3.0, which is a very good improvement compared to the previous version, is that it is more in line with the object-oriented aspect of Python. So what do I mean by that? So for example, you want to have different experiments. One experiment is, let's do not pre-process the data, right? So I want to see what are the predictions of the models, what are the better models if I do zero pre-processing, right? I'm gonna import something called experiment, for example, regression experiment, classification experiment, and then before writing the setup, I'm gonna say, let's say I'm gonna define experiment, and then here, out of that experiment, let's say I call it experiment number 1, I'm gonna say experiment 1 dot setup. So it's an object coming from that experiment. So the cool thing about it is that I can have multiple experiments in one notebook, and without running the entire code. So previously, in the previous version of Pycaret, you have to run the entire from A to Z, and then if you want to do a new experiment with pre-processing or different version of pre-processing, you have to run the entire thing one more time. But now, based on this new features, the object-oriented feature of the Pycaret available in 3.0, you can do it right at the beginning. You can have different experiments, and then you can create models based on different experiments. So for example, I can say random forest coming from experiment number 1 with 0 pre-processing, random forest coming from experiment number 2 with this amount of pre-processing. So yeah, again, we're going to look at some detailed example later on. That was the supervised version, and this is the unsupervised version. Again, we can just, here's the snippet for clustering, and this is for anomaly detection. And as you can see, we're talking about 5 to 10 lines of code at most. And what's being done under the hood is really impressive. All right, now let's see how can we install this interesting package, right? So the most efficient way of installing Pycaret is through virtual environments like Anaconda, Miniconda, Miniforge, you name it, right? And I'm gonna do a separate video for how to do all these steps, but this is what you should keep in mind. Again, go ahead and install your Anaconda environment, create an environment, you can call it Pycaret, activate that environment, and just run this line of code, pip install Pycaret. So the difference between Pycaret and Pycaret Full is that the Pycaret alone is a lighter version, so some of the underlying models and the dependencies is not going to be installed, like XGBoost. And if you do bracket full, it's going to install everything, right? So can you install it on the Mac, especially Mac M1 and M2? My answer is you can, but it's not straightforward and easy. So if you have a Mac, I encourage you to run this Pycaret, the entire thing, on a Google Colab, for example. On Windows, again, as of December 2022, it works. If you simply do pip install Pycaret, open close bracket full, and then it's going to install the latest version of Pycaret 3.0. I have had some students getting errors, even on Windows. If you're getting errors, so probably a better route for you to do that is installing the Pycaret, the light version, and then install XGBoost separately. And then when you're running a notebook, call these packages separately. And yeah, I'm going to talk about these steps in the next video, but just keep in mind that the installation part shouldn't be that difficult if you do it in a separate environment. Okay, and finally, I encourage you to go through the important links on the Pycaret documentation API. If you go to their GitHub account or simply looking at the documentation API, just simply Google for Pycaret documentation. Basically, you can find a bunch of good tutorials, notebooks. I'm gonna put together a notebook for myself, which includes introductory level and intermediate level, and maybe some advanced things you can do with Pycaret. And yeah, that's pretty much it. So make sure that you watch some of these tutorials on your own and you check out the documentation. And the one last thing is, the latest version of Pycaret, they are doing some very cool stuff when it comes to time series. The time series module is available now with the main Pycaret installation. And basically like the classification and regression, well, like the basic functions that we already saw in Pycaret, the time series module is really, I enjoyed working with that. And I'll talk about the details of that time series in a separate video. Okay, so without further ado, let's try to look at some examples, some practical examples in Python. So you should be able to find these practical examples on my GitHub, the repository for the machine learning course at USU. So this is the address of my GitHub. Just simply Google it, PJ Algotrader, and then machine learning USU. And then in the main branch, you will find a folder called Pycaret, and there are three IPy notebooks, one for classification, one for regression, one for time series. Good luck and see you in the next one.